Why settle for incremental growth when you can boost your revenue, cut costs, and adopt new technology more quickly? Why navigate the complexities of AI and the complex tech projects or technology projects alone when you can have insights from the forefront runners and the innovation providers such as Glorium Technologies? What the world's leading AI and technology experts are doing right now to transform healthcare and life science organizations and drive unparalleled growth right now is what we're discussing in these podcasts. This podcast is your gateway to the answers, providing a deep dive into the world of artificial intelligence and its power to amplify your revenue, to cut costs and adopt those efficiencies that are critical to deliver patient care, especially around healthcare and life sciences. So my name is Dudley Peacock, and I'm joined by our AI and technology expert, our resident expert, Dmitriy Stepanov. And welcome to our podcast, The Revenue Amplifier, AI in Action. Today, it's going to be quite interesting today. Today, we're getting to the really meaty bits. So today, we're getting quite technical, although we're going to keep it nice and light. So today, for healthcare and for life sciences, one of the big technologies, one of the big things that have really taken on the AI progression over the years and have really seen results, tangible results in the specific space. And that is to do with AI, the imaging side of things and the diagnostic side of things. And when we look at healthcare and life sciences, the diagnosis of patients, to speed it up, to be more accurate, to be to pick up anomalies that you might not see as a human being. Sometimes you might have 2 or 3 maybe doctors having a look at a particular diagnosis to get maybe consensus in terms of what the next step should be. But with the advent of AI, this is progressively getting better and faster and more accurate. So today we're going to cover. I was going to quickly go through things like image segmentation and quantification, analysis of medical images. I mean, that's quite interesting. And then patient data, because as you can also have a cumulative data of a patient over a period of time to see progression of diseases or regression of diseases, etc. And then if you're going into things like image-guided interventions, surgical procedures. And then I'm going to let you tell the stat, the difference between 2017 and 2023, what the increase has been. And I'm going to leave that as your bit to share. We're also going to cover a few things about the multi-layer perception networks, etc. And I think it's time. Let's just get going. So, Dmitry, off you go. Shoot.
Well, yeah, that's a lot of information, but we will try.
A lot of information, eh?
Yeah, within next, 25, maybe 30 minutes. So Dudley, I mean, artificial intelligence and I guess particularly deep learning algorithm, they showed remarkable capabilities in extracting a very valuable insights from the medical images. I mean, those deep learning models trained on the large data sets, they can recognize complex patterns. They can recognize some features which, in most cases, are either not readily discernible or very hard discernible by human eye. So basically, and first of all, this one, and then the second one, they're consistent. So again, people are people, humans are humans, and those algorithms, they are consistently producing the same results over and over and over again, right? So that's, I guess, one of the benefits of using artificial intelligence in image recognition. Additionally to this, those actually artificial intelligence in image recognition, specifically in healthcare, they can provide, I guess, perspective about which features in the image should be valued, should be used to support decision, because in some cases we see that this is an artifact, this is a tumor, or this is something else, and that's why it should be treated. But basically training those artificial models and connecting them images and outcome, those algorithms, those models can actually show us additional features that we were not aware about before. So I guess that's one of the major benefits of the imaging in healthcare.
Okay, so what's really interesting, Dmitry, is it's almost like having like a Sherlock Holmes, a detective, being able to be consistent, like a 24-hour, 7 days a week detective that's always awake, looking for clues, looking for those things that sort of, let's call it, the average person cannot see. And if you look at the average doctor, they're well trained, but they can also have off days. They're human. So some days they could be overworked, they could be tired, and AI brings in consistency. And I think that's a very special point around AI, is that consistent high level of output. So I don't know, that for me makes a lot of sense.
It does. I mean, that's just, I mean, I definitely don't want to undervalue the opinion of the doctors, especially from the image recognition. But I think what's important to recognize here, that those algorithms, those models, they do help to make it more consistent, more efficient, more effective. No replacement yet. I mean, again, as I said before, we were not looking for the replacement in the near future, but there is help, there is mentoring. I mentioned, I mean, I use this term several times, and making sure that the results are consistent is very valuable, and you cannot overstate it.
Surely speed is also a thing. So because it's more like a helper than it's replacing the doctor. So it's helping in terms of speed and accuracy. But imagine being able to do 5 or 10 times more patients in a day than what you would normally be able to, as an example. I mean, that is significant, because if I remember the old days of going to a chiropractor, for instance, you had to go in for an assessment, and then you take a good time to do the adjustments and so on. And when I saw the new ways chiropractors do it, is they literally lay people on a tables next to each other on a row, and then they just go click, 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 click all the way down, and they manage to look after 5 times more patients. It's almost that type of thing, but just making things a lot more efficient.
Well, I mean, since you mentioned speed, there is actually 2 factors that affect the speed. Well, as you mentioned, it's speed from the handling more patients per unit of time. And another very important aspect is early detection, because some traditional methods, they do not allow you to detect early stages of cancer or any other disease. But especially if your eye is not sufficiently trained, again, if you are not in focus, you are not in resource, and those artificial intelligence, specifically algorithm, they can improve speed from the point, again, early identification, early intervention, making sure that it's easier to treat, it's recovery is quicker, and so on, so on. I mean, you can just keep talking and can keep showing the benefits from this standpoint.
Yeah, that's very important. Early diagnosis. I think a lot of doctors, and I think us men sometimes, just from a reality point of view, we don't tend to go to the doctor. And when we go, we try and get out there as quick as possible.
Yes, only when it hurts, right? I mean, that's hurts. So now I need a doctor immediately.
Only when it's really, really bad. So maybe if there is a health check that's easier for patients, let's say someone who's busy, they're at work, they have to take time off, it's also quicker for them potentially to get through a complex diagnosis quite quickly without taking time away from their productive time, for instance. So it's not just a healthcare benefit, but it's also a patient benefit.
You're absolutely right. And I mean, kind of to develop your thought in this direction, especially now with generative artificial intelligence, with I guess in combination with old approaches to the artificial intelligence interpretation, detection, and so on, and using, I guess, patient data, current, well, I mean, it is kind of related to imaging that we are handling here, but I think it is directly related, because those algorithms, again, using the images, because they still process images, they use patient data, and they can generate patient-specific insights, I guess, which enables tailored treatment plans with individual variation because of, I don't know, anatomy, physiology, or some disease characteristic stage, life cycle of the disease. And obviously, those personalized approaches, just like everything personalized, I mean, they do enhance treatment efficiency, and they do minimize risk of the side effect, and obviously improve patient outcome, reducing cost for the healthcare. I don't know. I mean, and again, I can just keep talking about what the benefits here.
Yeah, because I remember at one stage, if you take something like an X-ray,
Yes.
too many X-rays can give you radiation problems, and can, you know, and I think even those that have to perform the procedure, we're trying to protect them too. But from a patient point of view, you try not to have an X-ray every week kind of thing, because it's actually dangerous. So if you can do better analysis quicker, get more data at one time, the efficiencies obviously are significant too. So I'm guessing, like, everywhere we look, every angle we look, AI is having an impact. Can maybe just, instead of just talking about the positives, what are some of the negatives? Let's just maybe just touch on that briefly, because in future episodes we also have to talk about some of the dangers and why you need specialists like Glorium Technologies to come in and to assist with the implementation of those AI technologies.
Yeah, I can tell you about this. So just, I mean, I guess the example that I can bring is amount of I guess new technologies, new views. So just to give you, I guess, taste of the amount of new information that coming in this area, just from 2017 to 2023, there are the growth of researches, publications, reviews, white papers. We see 10-fold increase. So, and basically you see 10-fold increase on the information that you can use to improve your process, your product, your current procedures, and so on, so on. And I mean, to be frank, this is almost impossible to keep up with this amount of innovations in this area. And each innovation is actually very important, to be frank. I mean, in 2023, we saw so many changes in image recognition, in generative industry, imaging, and healthcare as well. They're just navigating through all this amount of data. You need someone's help. And I mean, we as a Glorium Technologies, obviously, we have an expertise, we have experience. We did multiple projects that are related in artificial intelligence, healthcare. We are, healthcare industry is a conservative by definition. And while we do offer latest cutting-edge technologies, sometimes at the end product is a little bit toned down, I would say, but not significantly, because I mean, you need to make sure that this is a tested technology, it actually proved itself, it actually will bring value to the product. And every time when we assisting basically in developing any feature, not just artificial intelligence, we do help to show the value of this feature, the value of this improvement from the revenue standpoint, from the, in most cases it's a revenue standpoint, but in some cases it's a reduction in the expense, which is, obviously affects your marginality. So connecting this technology and business vision and finance aspect is very important, and we do help in this direction as well.
Yeah, because I'm just thinking about the workload. If you look at internal technology teams inside different healthcare and life sciences organizations, whether these are actual technology businesses or they are providing patient care or whatever the environment is, their internal technology teams are very, very busy with their technology infrastructure. They don't necessarily have the time to sit and go through this kind of research. On the other hand, doctors and specialists and these kind of people also don't have hours and hours of time to wade through all these different reports and so on to find something that may or may not work for them, because they would need to test it, they would need to talk to someone, there's a whole host of proper procedures you have to follow to get it implemented. So I'm guessing that with that amount of new papers and things coming out at an increasing speed, having specialists that are geared and are focused on this as a specific topic and this in a specific niche is important, because in that way you can actually give the best possible advice because you are closer to it than most, even if you're dealing with people that in those particular entities or organizations.
You're absolutely right, but I just want to add one more thing, which is important and very frequently overlooked, because a lot of, the companies we've been working on, they already had specialists in the areas that we're developing. And they were positioning themselves as experts in those areas, and they probably would create something decent by their own. But the biggest value that, for example, Glorium brings to clients like we have, I guess, is a variety of the knowledge. Because yes, you can be a specialist in the one specific niche, but that prevents you from, I guess, looking at the picture a little bit wider and seeing some other solutions that are much, much better. And sometimes it just, you just didn't think to look in this direction to use this specific solution. And this spectrum of possible solutions, having this spectrum and actually using the spectrum is essential, especially right now, as I said, with this amount of new researches, with this amount of new white papers or publications, achievements, and so on, so on. So it's not anymore about having a specialist in one specific niche, but it's having this wide vision and seeing everything and proposing different alternatives that can bring this value or that value, depending on the business vision. And actually mapping business vision with the technologies is very, very important, and very frequently we see mistakes when not, I guess, best ROI solution is selected and something better could be used to improve the product value or revenue increase, or specifically targeting the audience, clients, and so on and so on.
Yeah, I suppose if you look at ROI, return on investment, many times the decision is made based on how do we get it cheaper and faster, as opposed to how long can we keep on with this, and what are the other impacts if we cut back too much. I love your way that you said it's actually also having a broad view of AI and the impact across multiple areas within the space, but also having the depth as well. If we go into, so we spoke about AI imaging and for healthcare, what they're used for, etc. The image segmentation and quantification. Just give us a little bit of an idea what that is and how it gets used.
Well, I guess let's go a little bit to the history of how imaging recognition was done over the past few years. So I guess the earliest application of the artificial intelligence image recognition were using the multi-layer perception networks. It's basically neural networks that somewhat direct reflection of our brain. So basically you have a node and you have a connector between nodes and you have weights, and then you train your neural network with these weights to basically adjust your neural networks that for specific input you have specific expected output, right? But those early models, they actually had a lot of limitation because of the performance, computer power, and they didn't look at the image as a, I guess, system. They were looking for specific elements, curve, template, color, something specific, maybe some shape, and this is it. I mean, and well, I guess the next generation that we're using so-called convolution neural network, they made some improvement in this direction, and that's actually where we started to see a lot of decent artificial intelligence image recognition algorithm. And actually it was inspired by how animals vision system works. So basically it's a recognition some features, so and again like age, corner, texture. So that's we actually literally copied animals. So I guess now it's time to copy humans, right?
Yeah.
But but the thing is, it's well, I mean, those approaches they called CNN. Those models, they were good, to be frank, with grid-like data. So you give it an image, specific image, and it will find you some artifact, some deviation, or something that you're looking in this image, okay, and it will process. But it didn't analyze those pictures in the context. What I mean here that, for example, if in one image you might have multiple artifacts. So those models, they would say, well, this is artifact number 1, artifact number 2, artifact number 3. This is it. Or if you have a series of the images, like DICOM image, and you move through those slices, and okay, I found artifact here, and then I found artifact here. So, and they would just say, well, I found 2 artifacts in different layers, and this is it, right? So obviously you can put algorithm, you can connect it, you can say that something, a number of deviation and a number of artifacts, and therefore conclusion this and this, but it was more algorithmical and not always very useful. But remember, on one of our previous podcasts, we mentioned transformers. So transformers, it's basically a latest generation of artificial intelligence when the data is analyzed in the context of the data itself. So, for example, if you providing a sentence to language learning model, for example, right, a large language model, then it will use the entire sentence to analyze specific word in the sentence. So it's using context. So here with the vision transformers, they were able to produce something similar. They were able, they would divide image into several pages. They would analyze each of these pages separately and then connect conclusions as a one big system, as a one big picture. And therefore, that would be able to connect different aspects, different artifacts, different deviation, not just in like spatial, but in time, so sequence. So it would be able to analyze the video and basically connect second number 1 and 3.5 second images and saying, well, those are connected, and more likely this is a disease because of these 2 specific frames in this video. And this is basically one of the latest advancement in the image recognition. It's not widely used yet, but we see a lot of interest in this area and a lot of progress in this area. And I think the next generation system will be using this VIT architecture, basically analyzing images as a system and analyzing videos as a system and making conclusion based on several artifacts and connecting them together. So
it's actually fascinating because it's almost like you're getting a multi-dimensional view. It's like going from 2 dimensions to 3 to 4 to then more.
yes,
Because I think humans, we can see 3 dimensions. I think we think we can see 4 sometimes. But I think if you look at AI, it can probably do multi-dimensions, probably unlimited amounts of ways of looking at images. Right, that's fascinating, Dmitry. So there's so many things that we can take from this kind of conversation, because I think people are not really aware of the power that sits behind a lot of these AI technologies that are coming out.
right.
If we look at going straight back to sort of generative models, because we had predictive and we got generative. We had covered that in one of our earlier episodes, sort of what's the difference between the two. But if we look specifically in this space, the generative models, let's tackle that a little bit.
That's actually a very interesting topic because, I mean, yes, as you, Dudley, mentioned, we did review it before, but I guess put them on the spot to some extent. Remember, we're talking about 5-legged animals, 5-legged elephants, and so on. But surprisingly, generative imaging is, well, I cannot say widely, but it is used in the healthcare industry. And what's interesting, it is used to generate those artifacts that resemble real data, that resemble some disease artifact. And the purpose of those approaches is, that's actually sounds very controversial, but works very well. It's actually used for the training data. So you say, well, wow, you literally need to train your model to generate some artifacts. So in order to train actual model, well, I mean, if you do it properly, yes, you can do this. And usually it's used in the industries where the real data is not available, or it's a very, I guess, a small data sets exist, and therefore they cannot be used for the training. But we knowing, I guess, how those artifacts can look, and we can train those models so they can be general models, and they can actually recognize those artifacts. So as I said, it's a very niche area, very sensitive area, a lot of arguments going on because of the sequence train, generate, and train on the generated images. But it actually does work, and actually it does provide some help again where the data is not available.
I'm guessing if you look at something like the pandemic, the COVID pandemic, for instance. So when there's a new disease, or when there's a particular thing that only happens to a small percent of the population, maybe when they get diagnosed, it's potentially too late sometimes, because it's not a regular or a more common kind of disease, or common kind of virus or bacteria or something like that. So to simulate, and I think that's what you're talking about, is to simulate as if this has now actually happened, to then train the AI on a simulated model.
Yes.
To get a way of dealing with that particular thing when it does arrive, because our data sets are potentially too small, or that we didn't collect the correct amount of information early stage. They could maybe have only diagnosed potentially after someone's passed away, and now they have to do retroactive diagnosis to see, okay, how does this thing start? Where does it come from? They've got to try and simulate that model. So I'm liking that as a concept. How that works in real life, I'm sure there's, like you said, there's a lot of debates busy happening. Can you train AI on generative AI? That's interesting as a concept on its own.
Yeah, well, I mean, that's actually, I guess, a little bit off topic, but right now what they are discussing right now is the limitation of the generative AI in general from the image generation standpoint, because the opinion that is being discussed these days that, well, you don't need to be very creative anymore, for example, with imaging or with painting, because all those generative models, frameworks, they can produce pretty much any image. But the problem is those systems, they were trained on the human-created images, and they were trained on those human-created images. And because, as we were discussing again before, artificial intelligence is not very creative per se. It's just generating based on the some information that they learned. So at the end of the day, they will use up, I guess you can use this one, their data they were trained on, and they will not create anything more creative. And new models will not be able to train because, well, if human will stop creating new images or new creative things, those artificial intelligence model will just stuck at our current age, and they will not be able to develop anymore. So that's actually very interesting to see where
but that's a philosophical debate, though. I mean, that's assuming humans will stop being creative, and there might be different people with different opinions about that.
It's true. Yes. Well, I mean, but what I'm saying, I guess I want to address that again and again, pretty much every podcast we're recording. Artificial intelligence will not replace humans, because there are a lot of opportunities for humans. I mean, after all, we survived many
and we hope humans become more creative, because there's just so many problems to solve. But and I think this is what's really going to happen, is that it will allow humans to be even more creative without the drain or the drag of the mundane sort of repetitive things that are holding us back. We can be more free and more open and do our own hallucinations, if you like, and be more creative in the bigger picture. Let's finish off by quickly going to public data sets, because we're coming to the end of the 30 minutes or so. Let's just talk a little bit about that, how that applies to the healthcare and life sciences.
Well, I mean, life science and healthcare, it's somewhat public data, and it's very open from the information standpoint, from the data set standpoint, and a lot of data sets related to medical data, it's already exist for training the model, for verification, for benchmark model. And we're talking about imaging, and there are a lot of data sets like BRATS, KITS, LEADS. Those basically provide either image studies for training purposes, or to measure the efficiency of the model to detect these or another diseases. Obviously, there is a huge trend right now related to collecting data for further using it for training data, some proprietary data sets, a lot of interested in this area. And that's actually, I guess, the same issue we were were discussing before in slightly different aspect. But some companies, if they want to produce something unique from the artificial intelligence standpoint, they need first to collect the data in order to analyze it and produce something, and use this to train their model on this data. So that's very important aspect in the developing product, or developing some automation in the processes, and so on. So I guess I wanted to emphasize on this one also.
Yeah, and I think it's, if we just go back, make it more practical. Some years back, I did a DNA test with one of the DNA companies as an example.
Right.
I see there's other companies that are also doing DNA tests, but they try and position themselves differently, because some would do it for particular reasons, say for sport, food, diet, etc., or maybe some kind of lifestyle thing, or preventative disease, where others will do it for some other reason, etc. So maybe to keep a record of your DNA, because for your, for bloodline, for people coming down further generations, or I don't know, whatever the purpose is. But they're trying to do competitive advantages around this thing. So you're going to have proprietary models that will come out based on, I've got this technology, this makes me special, therefore you must pay. And then there's the other side, which is more about contributing back to humans. Because if I think about something like people offering their organs once they pass away, they're for, say, organ donors, or while you're alive, you go and give blood, kind of thing, and that sort of thing. That people want to contribute, but there's also some people that don't want to share their data, if you like. So there's always going to probably be this competition between public and private, and then this competitive force, and trying to differentiate yourself, because people still have to make money. I mean, these kind of things don't develop themselves. Somewhere, somebody's got to end up paying for some of these things. So I'm guessing that it's going to be a combination of public and proprietary or private sets, if you like.
Well, it's okay. I mean, competition is always good. It always accelerates the development, proprietary development, public development, open source, or some private development. So I don't see any issues in this segmentation between public data and proprietary data. It's all for common good. So I would support both approaches with no hesitations.
Yeah. So look, I mean, that's been a fascinating episode. And there's only one of quite a few of very specific topics in the episodes that are coming. I invite you, please, to absolutely log in it for our next episode. I maybe just want to, at this time, Dmitry, we now have a place, a special landing page for our Chief AI Officer offering, and you're going to see the link in the description below. And I would really invite you, if you just want to have a conversation about AI, what it means in healthcare and life sciences, go onto that landing page, go onto that page, watch Dmitry. He'll even give you a quick few-minute overview of what you'll be discussing in a particular meeting. There is an opportunity for you to have a workshop with your leadership team. And I think these are the kind of things that'll open your eyes to what's possible, but also where to be careful. And I think this is why you need people like Dmitry and his team from Glorium Technologies to be able to have those conversations. You don't have to do anything. You can just have a conversation. And I think that's really where we need to take it next. I don't know. What do you think, Dmitry?
Yeah, absolutely. Because I mean, well, first of all, it's very hard to cover all the topics during our recording, because this domain is so wide, and a lot of new stuff coming every day. It's much more efficient to discuss it within the context for specific application, for specific usage, for specific product. We can definitely outline different options, milestone, possible solutions, opportunity, low-hanging fruits, maybe some more complex solutions that will bring benefits from the revenue standpoint, or expense cutting standpoint, or keeping the product comparable and competition, and moving it from the marketing standpoint. So we can actually advise from different aspects and make sure that you are on the right path.
And it doesn't have to be a one-off. It can be regular communication, because I think as things go, they're definitely speeding up. But I think one of the key things and the messages I want everyone to take away today is that every week it's changing. And it's changing so fast that you must be doing something right now. And even if it's just starting those conversations within your organization, within your teams, start those conversations, but also have experts like Dmitry and Glorium Technologies coming in and just sharing. They have a 90-minute sort of presentation that they'll run through some of the key elements, and then you can sit and debate what's good and what's bad, what's important for you to be looking at right away. Yep. Thank you, Dmitry. Great conversation again. This imaging and this diagnosis of different images, and the way AI can do it, both generative and predictive, unbelievable. Things are just moving at a rapid rate. Great episode, and we'll see everyone again next week.
Next week. Bye.
Thank you. All the best.